Howdy, welcome. This is kind of an abrupt video that I'm making, so I kind of found something, wrote about it, and now I'm making this video all in the one day. I wasn't going to make this until maybe the next day, but I figured, you know what? Why the flip not just make it now? So that's what I'm doing. So enjoy the video and let's get right into it. Why did I put an ad? You know what? Never mind. First of its kind research conducted by Edith Cowan University, as well as a multitude of international parties, have now accurately determined the amount of carbon sequestered, or in layman's terms, locked up in the soil in salt marshes, mangroves, and seagrasses, or blue carbon ecosystems. This research was conducted in Australia and is it is about the Australian blue carbon ecosystems, or their carbon cycles. And what they found was that salt marshes, mangroves, and seagrasses all sequester 20 million tons of carbon annually. The goal of the research paper is to provide insight into the conservation efforts of blue carbon ecosystems. And what this is going to help with is it's going to help Australia work towards the Paris Climate Agreement. So you're probably wondering what the hell this blue carbon is if you don't already know it. Well, that's where I'm going to help explain it to you, because it is quite an important process to understand, because it basically keeps us alive. So blue carbon is basically carbon stored in coastal marine ecosystems. That's pretty much it. That's blue carbon. Now, I wouldn't be doing my job if I didn't explain this in greater detail, so let's jump into it. These blue carbon ecosystems act as a sink for carbon dioxide, or carbon. And what happens is that within these blue carbon ecosystems, they'll take up CO2 from the atmosphere, or atmospheric CO2, and lock it up in the soils, where it binds for thousands of years. You're probably wondering if there are other colors to this spectrum, or if it's just blue carbon. Well, you'll be pleased to know that there are actually 3 other kinds of carbon. You've got green, grey, and brown carbon. Green carbon is the carbon found and stored in rainforests. Grey carbon is stored in fossil fuels. Brown carbon is carbon stored in industrial forests, or forests used primarily for logging purposes. But these don't matter. We want to talk about blue carbon. Green carbon matters, but blue carbon more importantly. Let's talk about that. While the green carbon cycle, as I explained, the rainforests are an important cycle for atmospheric CO2, they're not nearly as important or nearly as effective as the blue carbon cycle. Now, in the green carbon cycle, CO2 will be taken up into the trees through photosynthesis, right? This gets stored into the tree for as long as the tree is able to survive, which is typically around 100 years, roughly. Or if it falls over, or dies, or catches on fire. There's a lot of variables, but typically 100 years. Now, in blue carbon cycles, the carbon gets taken up and gets sequestered, or locked up within the soils. This is where the carbon stays for thousands of years. The reason for these huge time periods in these blue carbon ecosystems is because of their slow decaying period. In green carbon ecosystems, they have very fast decaying time periods. This is because they have a lot of oxygen available for their leisure, or their leisurely use in the litter or in the decomposers, right? In the blue carbon ecosystems, because it's primarily marine based, the oxygen content is rather low. So once it gets caught up in the sediment, it cannot decay fast enough, and therefore stays for longer periods of time, or gets locked up. Mangroves are a great example of the efficiency of carbon uptake. In fact, mangroves account for 0.7% of the tropical forest areas, but take up 4 times more carbon than rainforests on a per hectare basis. Stack that on top of the fact that they are very important nurseries for many marine animals and juveniles. They also help coastlines from flood prevention, and they are also known to prevent tsunami surges from storms. So it doesn't take a brain surgeon to understand the importance of these ecosystems. Mangroves can't get all of that spotlight. You know, we can't give them all that limelight. Salt marshes and seagrasses play their part too significantly as well, if not on par to mangroves. In fact, as I stated before, they sequester about 20 million tons of carbon annually. Put that into perspective, that's about the same output as 4 million cars. Okay, so you know the importance of these environments, or you do already know how important these environments are. What are the issues involved here? These environments sequester a lot of carbon. That's a fact. We know that now, and it's accurately determined to be roughly around 20 million tons of carbon annually. When these habitats are destroyed because the carbon is locked up for a long period of time and doesn't decay for a long period of time because of the low oxygen content, when we destroy these habitats through industrial means or through dredging or through increased heat waves or violent storms, we don't do that, but the increase in violent storms, then all of that carbon that is trapped in the soil gets released back into the atmosphere. In fact, it's been estimated that around 3 million tons of carbon gets released back into the atmosphere after damages. Annually, mangroves are being lost at a rate of 2%, with their amount of land available for them being lost globally 50% in 50 years. Salt marshes are being lost at a rate of around 1 to 2% annually, with their global coverage being the same as that as mangroves, 50% globally in 50 years. Seagrasses are being lost at a rate of roughly 1.5% annually, losing 30% of their global coverage. To put that into perspective, seagrasses cover about 0.2% of the ocean's floor, but amass around 10% of carbon take-up annually. We've finally been provided accurate data on the importance of blue carbon ecosystems on climate change. What the researchers are trying to stress is that if we continue to demolish these ecosystems with industrial utilization or through urban development, then we're going to have a major problem, because knowing that they take up 20 million tons of carbon annually is kind of gives you an insight into the fact that these ecosystems are buffering us from probably some of the worst climate experiences that we could ever see. Now, if that doesn't convince you, this next part might, because it involves money. And a lot of money. The report also states that economically, restoring and conserving blue carbon ecosystems is a massive cash grab for Australians. Based on the current carbon trading models showing $12 per tonne, researchers have estimated that the conservation of these blue carbon ecosystems can amass you tens of millions of dollars annually, just for conserving and protecting these ecosystems. I mean, if that doesn't convince you, then I don't know what will. If the science won't help you change your ways, and the money, which I don't understand why it wouldn't, help you understand what's going on, then all in all, the fact that we can now accurately determine how much carbon these blue carbon ecosystems sequester is a huge bonus for, one, the conservation of the environment, and two, a huge bonus for the battle for people to understand the climate crisis that we are currently going through. Probably the 6th extinction. Is that a bit extreme? No, it's pretty accurate. Anyway, I hope you liked that video. That was kind of like a real short one, maybe, I'm not too sure. I just made that, or found that, I didn't make that up. No, I found that online. I'll put the links down below as I was browsing the interwebs. And I was like, you know what, I'm gonna write a video on this and see where it goes. So yeah, I figured I'd bust that out real quick. Hope you liked it. If you did, make sure you subscribe, share it around. It truly helps. We gotta get to that 100 subscribers. Please, let's just get there. I think we're sitting at like 76. Even, let's just get to 80. You know what, maybe 100's too far for now. Let's get to 80. Let's just, you know what, no. Dream big, people. Let's get to 100. Hope you like that video. Make sure you educate, don't eradicate. Like, comment, and subscribe. Share it around. And I'll see you next week for another video. Bye.